Hello friends, welcome back. In this session, let's try to briefly understand about continuity of a function. So we have seen in the last sessions about how to calculate the limit of a function and what is the limit of a function. So with that understanding, we can go ahead and try to briefly understand about continuity of a function. So to have a better understanding of that, I have taken couple of examples. Let's just try to go through this and understand. Now let's look at the function, graph of the function which is on the right hand side. We have a function f of x is defined by equal to 2 if x is less than or equal to 0 and its value is equal to 3 if x is greater than or equal to 0. Now if you look at this particular function graph and we want to find out at x equal to 0 how this function is behaving, you can see that when you come from the left hand side to the 0, so what we mean to say is as x tends to 0 minus, that means we are coming from left hand side, f of x limit x tends to 0 minus f of x is equal to 2, whereas limit x tends to 0 plus, that means we are coming from right hand side, we can see the value of f of x is equal to 3. Not only that, f of 0 is equal to x equal to 0 is equal to 2. Now let's go to this function and see what's happening. Same at x equal to 0 only. Now first I will see what is left hand limit. Right? This is the meaning of left hand limit only. I will write it down. Limit x tends to 0 minus f of x equal to. So we are coming from the left hand direction. So to 0. You can see that the value is towards 3. Not only that, if I come from right hand side, that means we are calculating the right hand limit, then also we see that f of x is equal to 3. I hope you are aware of how to calculate the left hand limit and right hand limit. In left hand limit we take x equal to a minus h and as h tends to 0. In right hand limit we take x equal to a plus h as h tends to 0. But this is very straightforward. We don't need to do that. We can see very clearly. It's okay. Now let us see what is f of 0. If I substitute 0, 0 plus 3 is equal to 3. So can you see the difference between them? In the right hand side, the function which is there on the right side, you see that the limit is not existing. 0 plus is not equal to 0 minus. Left hand limit is not equal to right hand limit. Not only that, it is also not equal to, both of them are not equal, and also it is not equal to the f of 0. So we call this function as discontinuous function, whereas on the left side we see that the limit exists and its value is also equal to f of 0. So this function is called as continuous function. So to be called as continuous function, 3 points should be defined. Let me just go through that. To call a function as continuous at a particular point, first f should be defined at that particular point. The function should be defined. F should be defined at that particular point. Suppose let us say we are talking about point A at which we want to check continuity. So first I should check whether the function is defined. Yes, the function is defined. The second point, the limit should exist. Limit should exist at A. That means the left hand limit and the right hand limit should exist at a. Both of them should be equal to each other. Not only that, the limit should be equal to f of a. What we are saying is, as x tends to a, limit of f of x is equal to f of a. If these three conditions are satisfied, then we will call that function as continuous function. Otherwise, we call the function as a discontinuous function. But in that again we have two types of discontinuity. We will discuss about that. If the limit is existing only at left hand side and that is equal to f of a, then the function is called as left continuous. If it is left continuous, that means it's automatically it is right discontinuous, because you are continuous only on the left hand side. Similarly, limit x tends to a plus f of x, that means right hand limit exists and is equal to f of a, then the particular function is called as right continuous. Now let's look at, suppose we want to find out whether a function is continuous not at a particular point but at a interval, then how we have to mention. So a function is said to be continuous on an closed interval a comma b including the boundaries if, first condition, f is continuous in open interval a comma b. That means other than a and b, at all points it is continuous. Second thing, limit x tends to a plus, that means from the right hand side, f of x is equal to f of a. Not only that, limit x tends to b minus, that means we are coming from the left, so we are coming from the left hand side for the function at b, that should be equal to f of b. If these three conditions are existing, then we will call that the function is continuous on the closed interval ab. Continuous on ab. I will repeat that again. A function is said to be continuous on closed interval a and b if and only if f is continuous in the open interval a comma b, that means all the values in between a and b, f should be continuous. Not only that, the right hand limit of f of x at a should be equal to f of a, and the left hand limit of f of x at x equal to b should be equal to f of b. So if these three conditions are satisfied, then we call that function is continuous on the closed interval. Now let us see what are the conditions where we can say that a function is discontinuous, either left continuous or right continuous. Let's look at that one. So when a function will become discontinuous, exactly opposite of what we have discussed for continuity. First, the limit does not exist. The limit fails to exist. What's the meaning of that? One of the limits, either the left hand limit or right hand limit, one of them fails to exist. Either the left hand limit or the right hand limit fails to exist, because if one of them is existing and is equal to f of a, then we can say it is continuous on that side. So either the left hand limit or the right hand limit, can we say like this: x tends to a minus f of x, limit of that, or limit x tends to a plus f of a, f of x, one of them is not existing. Second thing, the limits exist but left hand limit is not equal to right hand limit. That means x tends to a minus f of x is not equal to limit x tends to a plus f of x. That means left hand limit and right hand limit exist but they are not equal to each other. The other thing can be, these both limits exist, that means limit left hand limit and right hand limit exist, that means limit exists, both of them are equal but they are not equal to f of a. If any one of the conditions, we will say that the limit, the function is discontinuous. So what are those? One, either left hand limit or the right hand limit fails to exist. Second, if they exist but they are not equal to each other. The third one, they exist and they are equal, that's why the limit exists at that particular point but it is not equal to f of a. So this is how we can say that whether the function is continuous or not. So also what is left continuity, right continuity and the discontinuity. Let us summarize this. A function is said to be continuous at a particular point if and only if the function can be defined at particular point and the left hand limit and the right hand limit at that particular point exists. That means the limit at that particular point exists and is equal to f of a. If you are trying to find out whether the function is continuous at x equal to a. If these three conditions are satisfied, then we call the function is continuous at that particular point. If we want the function to be continuous on an closed interval, then the function should be continuous for all the values in between the interval, that means open interval should be continuous. Right hand limit of the a, if you are talking about a comma b as boundary, right hand limit of a should be equal to f of a, left hand limit of b should be equal to f of b. If these exist, then we will say that the function is continuous in the interval. A function is said to be left continuous if only left hand limit exists and is equal to f of a. A function is said to be right continuous if the limit exists only on the right hand side, that is limit of f of x as x tends to a plus is equal to f of a. A function is said to be discontinuous if one of the left hand limit or right hand limit does not exist or fails to exist. Second thing, they exist but they are not equal. They exist, they are equal but they are not equal to f of a. Any of the conditions, we say that the function is discontinuous at a particular point x equal to a. So in the next session, we will start a differentiation and try to understand first principle of differentiation and try to take it on from there. Thanks for your time. Bye for now.